This video is about reactions with alkanes. Generally, they don't react. There are really two types of reactions that they will go through. They are combustion and they will react with halogens. So combustion, you may remember from previously, is a reaction with oxygen. That's what combustion is. So reaction, O2 is a reactant. All right, so when you get that with an alkane of a hydrocarbon, your products are going to be carbon dioxide and water. So for example, you could have octane. So octane would be C8, H18. All right, so plus O2, you're going to get CO2 and water. Right, so you should take a second, pause, and balance this. So if I were to balance this, I would go through and say, well, there's 8 carbons, so I might put an 8 right here. Hydrogens, there's 18, so I might put a 9 right here. The problem with that is then that would give me an odd number of oxygens. When that's the case, I'm going to have to go back and I'm going to put a 2 here, which actually gives me 16 carbons. 2 times 18, so 2 times 18 for my waters. And then that will give me 16 times 2 is 32, plus 18 is 50 oxygens. So this is 25 O2s right there. Okay. When there's not enough oxygen, then we have incomplete combustion. So you are going to either get carbon monoxide instead of CO2, or if there really isn't enough oxygen, you'll get carbon solid instead of the CO2. So soot. So IB likes to ask about this and say, like, what are some problems with incomplete combustion, or why is it dangerous? Well, carbon solid would be dangerous. This is soot. If you breathe in soot, you're going to have particles in your lungs. Or carbon monoxide is a poisonous gas that doesn't smell, look, or taste like anything. So it could be very dangerous. It will put you to sleep to not wake up. So incomplete combustion of octane would look like still C8H18 plus O2, but it's not going to be enough O2. So you're only going to make, let's say, carbon monoxide and water. And here's where, again, we'd have to put a 2 here for 8 carbons. We'd have 18 waters, but what's going to happen here is you're going to get 30, oops, I meant to write 16 right here. You're going to get 34 oxygens on the product side, so you need a 17 here for your oxygens because you don't have as much. All right, so halogen reactions, these will only occur if there's ultraviolet light. This means you have enough energy for this to occur. So this is high energy. That's where that comes into play. So for example, you could have chlorine, which is diatomic Cl2 plus CH4. All right, it happens under UV light, and your chlorine, one of your chlorines and one of your hydrogens will switch places. So you're going to get a chlorine where one of the hydrogen was, and that hydrogen will go with the other chlorine. Okay. So how this happens, a mechanism is the process of how this happens. So this is called free radical substitution. A free radical is any element. I'm going to make a little note. So element or atom with one single electron. So it's written lots of times with the element symbol, just throw X in here, with one dot on it like this. Okay, so the initiation step, so this is the start. The start is UV light first breaks up that halogen from being a molecule where you have your chlorine, let's say this one, here are all its electrons, right, with 7, and you've got another chlorine. Let's see, I'll do these in green. No. Try that again. Actually, let's do this whole thing. All right, you've got another chlorine. Here are its valence electrons, right? And they're sharing the 2 in the middle. So that's your Cl2. The UV light will break them up so that you have separately your one chlorine free radical like this, and then your other chlorine free radical. So what they're looking for here is something to bond with. All right. So the next step is called propagation. This is where you get new free radicals that are produced. So you're gonna have to draw in the dots here. I'll do them in red. So this is if a chlorine free radical, we'll just put a little dot right here, comes across methane, let's say. Okay, it's gonna take one of the H's away from that. So here's where that H went, right here. And now you're making a new free radical right here with the CH3, okay? Then that CH3 free radical might come across a Cl2, take one of them away. So here's your chlorine where that free radical was. And then you have a new free radical of chlorine. Okay, so propagation is going to be you have one free radical plus a molecule, and that makes a new free radical. So free radical plus a molecule makes a new free radical, okay, which will then continue and come across another molecule and make another free radical, which makes another one, etc., right? It just keeps going. That's what propagation is. So when does this end? Well, it ends when you have two free radicals that combine, right? No more new free radicals are made. So these are all, like if I have a chlorine free radical and a chlorine free radical, it makes Cl2. Or a chlorine free radical and this CH3 free radical, right? They'll combine and make this. Or two of these CH3 free radicals, which makes C2H6. So all of these would be the end step, okay? All right, if there's enough chlorine present, each reaction doesn't have to stop at monosubstitution, which means it wouldn't have to just be one chlorine at a time. It could be multiple chlorines at a time. All right, so that is how alkanes react.